Hello everyone, I am Jeremiah. I'm a first class student of the Department of Mathematics. I'm also the best mathematics student in Nigeria and also the former president of Mathematics Department. So in this video, I'm going to be showing you how you solve questions. How you are going to solve question without losing point, that is without dropping point, without missing any mark, or what you need to solve and how you should. And I'm going to be giving you pattern of questions on how you are going to be solving it. And in my subsequent video, I'm also going to be teaching you how to solve some objective questions using calculator. This one is 001, wait for 002, 003 and 004 as well. So let's get started with this. Now, this is I'm going to be tutoring you on how to solve questions without losing or without missing anything. That is my main purpose here. Now, this is 2020. This is the first one I'm doing here is complex number. I'm treating 2020 question. That's your first semester exam. 2019 JUPEB final exam, mathematics, and 2018. So in 2020, complex number came out in the theory. Complex number also came out in 2018 theory, question number 1. So let's see how we are going to solve this. You can see this is 9 marks. Now question 1a. They say find the fifth root of 32 plus 0i. Fifth root. Let me say let z be equal to 32 plus 0i. Now we want to find fifth root, that is they want us to find z raised to the power 1 over 5. That is what we want to find. Now I'm going to bring you some background understanding of what you need to know about complex number. Please, you need to take note of this, especially if you don't know this before, that there are 3 ways we can express a complex number. We have z equal x plus iy. This one is called rectangular form or Cartesian form. It's called Cartesian form. Please take note of that. Z equal r cos theta plus I sin theta. This one is called polar form. The second one is called polar form. Then the last one, z equal r raised to the power I theta. This is called exponential form of a complex number. These are the 3 ways we represent a complex number. Now, if you want to convert a Cartesian to polar or exponential, what you just need to know is how to get r and theta. You can get r is square root of x squared plus y squared. That is what you need to know. You don't have to know x. This is called real part. Y is the one with I. It's called imaginary part. R equals square root of x squared plus y squared. Then theta is arctan of y over x. You need to know these 2. So look at what I'm trying to say. Why this is 9 points is because you must get 5 answers. You know, when you are dealing with fifth root, you must get 5 answers. That's what they want you to get. You must get 5 answers in this thing. So now look at what we have to first convert to polar form. And to convert in this case now, I have z to be 32 plus 0i. That means my s is 32, my y is 0. So I need to get r and theta. R is equal to square root of x squared plus y squared. That's square root of 32 squared plus 0 squared. 0 squared is 0, 32 squared. Square root cancels square will cancel square root. You'll be left with 32, or you can use calculator. Now, all this I'm doing here, I'm showing you the explanation because this is a theory question. Assuming it's OBJ, I will still show you in another video how you can use calculator to solve this in just few seconds, and you are done, and you will get your answer. Now, r equal 32, it remains theta. Theta is arctan of y over x. So this is arctan of y. Y is 0 over x, 32. 0 over 32 is 0. Arctan of 0 will give me 0 degrees. So theta is 0 degrees. So now to write this in polar form, don't forget, I have given you that this is r cos theta plus I sin theta. So you have r cos theta plus I sin theta. That is polar form. But now, if you are talking about roots, square, fifth root, like if you are talking about square root, third root, or fourth root of a complex number, this is how you are going to write your r, your z. Z, it will be r cos theta plus 2k pi. That's how you are going to write it. You want 2k pi. The reason is because 2 pi is 360. When you add 360 to any value of, to any argument or to any angle, and you press cos of that angle or sine of that angle, it is still the same thing. What am I trying to say? What I'm trying to say is that if you say cos 30 for instance is root 3 over 2. If you add 360 to cos 30, that's 390. If you press cos 390, you will still get root 3 over 2. In fact, if you add another 360 to it and press cos, the answer, you will still get root 3 over 2. They are always the same. The same thing happens to sine and tan as well. So that is why they are adding 2k pi. This k is just a counter. Just leave it that way, you will still understand what I'm trying to say. But whenever you see this type of question, this is what you are going to be doing. R cos theta plus this plus I sine theta plus 2k pi. Now, so that means Z is equal to 32. R is 34. I've forgotten that. Cos theta is 0. So I'll just be left with 2k pi plus I sine 0. This one is also 2k pi. 2k pi, that's what you are going to have. So you will now be putting, so z raised to power 1 over 5 will now be, this one too will also be raised to power 1 over 5. So this one will be 32 cos 2k pi plus I sine 2k pi, everything raised to the power of 1 over 5. So 32 raised to the power of 1 over 5, don't forget 32 is 2 raised to power 5. So 5 will cancel this 1 over 5, or you can just press 5th root of 32, or you write 32 raised to power 1 over 5 on calculator. You will get 0 raised to power 1 over 5 will be, this one will give me 2 open bracket cos. Now, look at what will happen to all these remaining ones. This 1 over 5 will come and multiply the angle, the argument, so that it will become cos 2k pi over 5 plus I sine 2k pi over 5. That is what you are going to have here. That's what you are going to have here. So this, what I have used here is called the Mobius Theorem, the Mobius Theorem. So, but then you don't need to state it, just apply it and just use it like that. And I'm true. So k will now be, see, let me tell you what k will be now. K, this is the k will help you to get all your 5 answers you are looking for. So k will start from 0. This k, you know, I said 2k pi. This k start from 0, 1, 2, 3, 4. Since I'm looking for 5th root, I stop at 4. If I'm looking for 7th root, I stop at 6. Do you understand my point? So that is what we have here. It was always start from 0, then stop at the number before the power of before the inverse of the power you have. Do you understand? So so the first answer, let me call it Z1. Put k to be 0. When k is 0, you have 2 times 0 is 0, 2 times 0 times 0 multiplied by anything will give you 0. So you will just left with 2 cos 0 plus I sine 0. That is when k is 0. That is the first answer. Because 0 is 1, sine 0 is 0. So 2 times 1, 2. So the answer is 2. That is the first answer. You can write 2 plus 0i. Don't forget, they say find the 5th root of this. Like, you need to find the complex answer. So that is the first thing you need to do. Now, the second one, I've gotten my first answer. Second one, when k is 1, put k to be 1. You have 2 cos 2 times k is 1. 2 times 1, 2 times pi. That is 2 pi over 5 plus I sine 2 pi over 5. You can leave your answer like this, or you do, what is 2 pi? Pi is 180, that means 2 times 180 divided by 5. 2 times 180 divided by 5 will give you 72. That's 2 cos 72 plus I sine 72. That is what you are going to have. That is the second answer. Is it that you leave your answer this way or you leave your answer this way? That is the second answer. Don't forget, you must get 5 answers. Assuming they ask me to find 6th root, I must get 6 answers. If I'm told to find 7th root, I must get 7 answers. This is the second answer. We call on Z3. Z3 is k is 2 now. You put 2. 2 times 2, 4. So here, this one will be 2 cos 4 pi over 5 plus I sine 4 pi over 5. You can leave your answer this way as I've said earlier, or you can evaluate further and say 2 cos 144 plus I sine 144. Then the fourth one, Z4. Z4 is when k is 3. Put k to be 3. So you put 3 here. 2 times 3 is 6. That's 6 pi. So 6 pi over 5. So you have 2 cos 6 pi over 5 plus I sine 6 pi over 5. Then the last one, the last answer, Z5, you have 2 cos times k is 4. 2 times 4, 8. Cos 8 pi over 5 plus I sine 8 pi over 5. So this is the 5 answer you need to obtain. Now, if you don't get anything, please replay the video. Pause it. Just replay the video, start again from the beginning and look at it. Make sure you understand it. You must not, if this question come out in your exam, you must not miss it. This is just the way to write it, and once you write it this way, you will have all your full marks. The whole 9 marks will be given to you, will be awarded to you, because I spent my whole 4 years in math department. I know how things go. So you must think like, you must just look at it again. Let me just quickly revise. Number 1 is you have this convert to polar form. So when you convert, and how do you convert to polar form? You need 2 things, r and theta. This is how to get r, square root of x squared plus y squared. Get it? Get theta, r tan, you get 0. Then use this whenever you are looking for raised to power of fraction. That is, you are looking for square root, cube root, fourth root, and the likes. This is what you are going to use, theta plus 2k pi, where this k must start from 0 and it must end at a number before what is here. Do you understand? So k must start from 0. Since I have 5 there, k must start from 0, 1, 2, 3, 4. That's where it stops. So you will now put theta is what you get here. I put it 0 plus anything, you see the same thing as that thing. So and this is 32. So raised to power 1 over 5. 32 raised to power 1 over 5 is 2. Then this one, this cos, whenever cos theta plus I sine theta raised to power something from the Mobius Theorem, I use the Mobius Theorem here. Whenever you have power and you have cos theta plus I sine theta, let that power come and multiply the angle. That's all. You are true. That's all you need to do. So that's what happened here. Then you will now be putting all these values, and that is the answer. Thank you very much. The second question, please. So now, express in polar form. Don't forget, express in polar form. This one too, you can use calculator. See, when I'm explaining in my next video on how to use calculator, I'm going to revisit all these questions. You can confirm, you know, after solving, you can confirm whether you are correct or wrong inside the examination hall. But if you want to do that, you have to be very fast so that time will not be against you. So the second one now, look at what I'm going to do. I will solve it because this is a theory question. You need to show workings. But assuming it's an objective question, I'm going to show you how you are going to use calculator to solve it much later. But pay attention to this now. I have 1 minus root 2 plus I. In this case, convert to polar form. I told you, whenever you want to convert to polar form or even exponential form, we just only need r and theta. And what is r? R is equal to square root of x squared plus y squared. And what is theta? R tan of y over x. But in this case, what is x and y? S is this one, real part. S is all these ones here. Anything that does not have I, and it's written this way is x. And the coefficient of I is y. So in this case, it means that S is 1 minus root 2 and y is 1 because the coefficient of I is 1. So that's what I'm going to do. So I'm going to get R now. R will be equal to square root of x squared. This is x, 1 minus root 2 all squared plus 1 squared. Square root of this one, expand this. Just do normal expansion. Just do 1 minus root 2, 1 minus root 2. Or you can just press calculator. Calculator will give you the answer. Just press 1 minus root 2 all square on your calculator. Calculator will help you solve and give you the answer. But in this case, about here, I'm going to solve from here. I have 1 plus 3 minus 2 root 2 plus 1. So 1 plus 3 is 4 plus 1 is 5. 1 plus 3 is, oh, that's 2. This one is 2. When you expand this is what you are going to have. You are going to get 3 minus 2 root 2 plus 1. So this one will give me square root of 4 minus 2 root 2. That is what you are going to get. That is your R. Leave it like that. Now to get theta, theta is equal to arctan of y over s. And what is arctan? Y is what? 1, don't forget. All over x. X is 1 minus root 2. So what is theta? Arctan. Just press arctan of this. Now pay attention to what I want to show you now. There's a mistake students normally make here. Please, and once you make that mistake, you drop point. What do I mean by you drop point? You may not get the full answer here. For you to have this complete full marks, you need to draw the Argand diagram. And what is the meaning of Argand diagram? Look at what is happening here. Draw the Argand diagram beside your work. This one is for real part, it's for the real as that is the name for x. This one is for the imaginary part, name for y. Now, 1 minus root 2. If you press 1 minus root 2 on calculator, 1 minus root 2 is minus 0.414. So minus 0.414 square, you know, this is the origin, 0. Here is positive x, here is negative x. So minus 0.414 here, right? This is where it falls. Now, and y is 1. Y is 1. Y, let's say this place is 1. So that means what you have here, if I call this one z, if I call this one z, that means this is where z is. Z falls at the second quadrant. In trigonometry, this is called second quadrant. This is first, second, third, fourth. Now, let me quickly tell you something. In the first quadrant, you have 0 to 90, right? In the second quadrant, you have between 90 and 180. In the third quadrant, 180 and 270. Then the fourth one, 270 to 360. So, what do I mean? The angle you must get here, this theta, must fall between 90 and 180. But if you press your calculator without wasting time, if you press your calculator to solve that, you are going to get minus 67.5 degrees. In fact, you are even getting a negative value. This is not what you are going to write as your theta. Theta must fall between 90 and 180. In trigonometry, for you to write an angle in the second quadrant, you do 180 minus theta. So theta will now become 180 minus this. Don't add it though. If you add it, you are going to get a value greater than 180. And don't forget, this is on the second quadrant. It must be between 90 and 180. So you do 180 minus 67.5. 180 minus 67.5 will give me 112.5. So 112.5 degrees. So this is the answer. So that means if I want to write this in polar form now, this is the representation of polar form r equals theta plus I sine theta. So z is equal to r. R is all this one, square root of 4 minus 2 root 2, open bracket, cos 112.5 degrees plus I sine 112.5 degrees. And that is the answer. Once you have written all these things, you have your full marks. You won't drop any point at all. So let's continue, please. The next one, 2018. Now let's look at 2018 question number 2018 question number 1. In fact, 1A. Question 1AI. You are told to compute 1 plus 3 over 1 plus I all square. Now, later I will show you that you can actually press all these things on your calculator and it will give you the final answer. I will still show you. Please wait for the video on how to solve with calculator, which I'm going to show you. I will show you clearly. You are going to see it. Now, after solving, you are now going to use that your calculator to confirm it, whether you are correct or wrong. So this one I did not know the marks because the past question I used, they did not write the mark allocated for this particular question. But then with that as it may, it will always carry marks. Do you understand? Now compute this. The first thing is find the LCM. LCM is 1 plus I. This one is over 1. 1 plus I divided by 1 is still 1 plus I. So this is 1 plus I plus this divided by this 1. 1 times 3. 3. All square. 1 plus 3 is 4. I have 4 plus I over 1 plus I all squared. So this square, that square you are seeing is for everything in the bracket. So I can write 4 plus I all squared over 1 plus I all squared. Even at this junction, you can press 4 plus I all squared on your calculator. It will give you an answer after I show you how to press it. And 1 plus I all squared, it will also give you an answer. But then you can expand. Let us expand now. If you expand this one, you have 16 plus 8I plus I squared. Then this one too, 1 plus 2I plus I squared. But don't forget, I squared is equal to minus 1 in complex number. I squared is equal to minus 1. So I will have 16 plus 8I minus 1 all over 1 plus 2I minus 1. 16 minus 1 is 15. So this is 15 plus 8I all over 1 minus 1 is 0, so I'm left with 2I. So I just the last thing I do is that I take away this I from the denominator. That means I rationalize. I multiply both numerator and denominator with I. So I multiply by I multiply by I. So this one will be 15I plus 8I squared over 2I squared. 2I squared is minus I squared is minus 1. So I'll be left with 15 minus 8 all over minus 2. So you'll be left with 15 minus 8 all over 15I. I've thrown away the I, so please take note of that, don't make mistake. 15I minus 8 all over minus 2. So I can write this as I want to write the one with without I first. So I have minus 8 over minus 2. That's minus 8 over minus 2. If nothing is in front, it means plus 15I over minus 2. Minus cancel minus. 2, 8 in 4. 8 divided by 2 is 4. So I have 4 plus times minus is minus 15 over 2I. And this is the answer to what you are going to do. This is the answer to that question. Now the second one that follows it, II. The second one that follows it, find a value of x and y respectively. Now see this question. I have 3 plus 4i over 2x plus iy is equal to 2 minus 2i. 2x plus iy is equal to 2. 3 plus 4i over this equal this. Now, instead of you to be rationalizing here, don't rationalize, cross multiply. When you cross multiply, 3 plus 4i times 1, anything times 1 is still the same thing as that thing. 3 plus 4i, that's what you are going to have. 2x plus iy multiplied by 2 minus 2i. So this is 2x plus iy multiplied by 2 minus 2i. So this is 3 plus 4i. 2x times 2, 4. 4x. This time this minus 4xi, right? Iy times 2 plus 2yi plus times minus 2yi squared. Don't forget I squared is minus 1. Please take note of that. So put minus 1 here. This one will become, this is 3 plus 4i is equal to 4x. I squared is minus 1. Minus times minus will give me plus. So I want to write it in front here, plus 2y, right? Then I have minus 4xi plus 2yi. Please, anything, if you don't understand anything in what I'm doing, pause it and look at it again. You will get what I've done. Do you understand? Maybe you don't understand this case now. This one, I squared is minus 1. Minus 2 times minus 1 will give me plus 2. So I just bring it to the front. Do you understand? Now, equating component wise. This is 4x minus 2y. It does not have I at all. That is the real part. That means 4x plus 2y is equal to 3 plus 4y is equal to 3. That is the real part because it does not have I. Everything that does not have I here will be equal to everything that does not have I here. This one has I and I. That is minus 4x plus 2y must be equal to 4. 4i. See, you know I did not put I, so it's equal to 4. This is a simultaneous equation. I will still show you how to solve simultaneous equation using calculator. So, but let's solve this one now. The elimination method. This plus this, just add it. Equation 1 plus this is equation 1, equation 2. Equation 1 plus equation 2. 4x minus 4x, 0. 2x plus 2x, 2y plus 2y, 4y. 3 plus 4, 7. Divide both sides by 4, 7 over 4. So to get x from equation 1, what do you have from equation 1? You will have 4x plus 2y is equal to 3. So that is 4x is equal to 3 minus 2y. And what is 3 minus 2? What is y? Y is 7 over 4. So 7 over 4. So that is 3 minus 2 here 1, 2 in 4, 2. So that's 3 minus 7 over 2. So if we take the LCM, LCM is 2. 2 divided by 1, 2. 2 times 3 is 6. I have 6 minus 7. 6 minus 7 is minus 1 over 2. So that means I have a 4x to be minus 1 over 2. Divide both sides by 4. If you divide both sides by 4 again, x will be equal to, just press minus 1 over 2 divided by 4 on your calculator. You will get minus 1 over 8. So that means x is minus 1 over 8, y is 7 over 4. And once you do something like this, you will get full marks. Let's go to another part of pure mathematics question. Let me quickly write the question. Wait for me. Now, this is the solution. This is the question I have now. So, this is 2020. You know, I told you I'm solving 2020, 2019, 2018, and I'm going to be showing you how to solve questions very well and very accurately. This video is going to help you. Now, find the equation of the straight line which passes through the point this and is perpendicular to the line 2x minus 3y plus 4 equals 0. That is question number 2 in 2020, your first semester examination. This is question number 2. Now, what will happen here? 2ai. Now, see what will happen. They ask me to find the equation which is perpendicular. First of all, start the equation 2x plus 2x minus 3y plus 4 equal to 0. That is the first thing you need to do. Make y the subject of formula. Bring y to the other side, you will be left with 2x plus 4 equal 3y. Divide through by 3. Y will be equal to 2 over 3x plus 4 over 3. So I have divided through by 3, then I decided to write from the right hand side. So this is what I have. So that means the gradient. See, why am I doing all this one? The reason why they gave me this line is to get the gradient. The gradient you have here is 2 over 3. But they say perpendicular. This perpendicular is very important. Assuming they say parallel. Assuming they say parallel or tangent. When you say tangent or parallel, when you get the gradient, use the gradient like that. But when you say perpendicular or normal, when you say perpendicular or normal, you don't use the gradient like that. You have to find a new gradient. And what is the new gradient? Your new gradient m1 will be minus 1 over m. So your new gradient m1 will be minus 1 over m. Please take note of this. This is very important. That's why they put perpendicular. Assuming they say parallel, use this. 2 over 3 is the answer straight. Use 2 over 3 as the gradient. But since it's this perpendicular, I have minus 1 over 2 over 3. So this is minus 1. At the end of it, if you press minus 1 divided by 2 over 3, you get minus 3 over 2. Now, what is the formula for equation of a line? So you have, the formula is y minus y1 is equal to m1 x minus s1. So assuming it is parallel, they wrote here, or tangent, I will not, this one will not be m1, it will just be m. That is, I would have put 2 over 3 here, but since it is perpendicular, I am going to put m1. Do you understand? So how do you get s1 and y1? That is the point you are giving. So at the point minus 2 comma 5. So the first one is your x. The first one is x1. The second one is y1. So that means I have y minus y1. y1 is 5 is equal to m. That is minus 3 over 2 open bracket x minus x1. x1 is, that's x minus 2. So that is y minus 5 equal minus 3 over 2 x plus 2. This is y minus 5 so that you can see it very well. It's equal minus 3 x plus 2 over 2 cross multiply. 2 times this, so I have 2 open bracket y minus 5 is equal to, let 1 times this will give me this. So let 3 open the bracket, you have 3x plus 6. So this is 2y minus 10 equal 3x plus 6. So bring everything to this side, you have 2y minus, so I'll throw away the minus. This is minus 3 minus 6. So don't forget minus is here. So there is a minus sign here, there is a minus sign here. So minus 3 times x minus 3x minus times plus minus 3 times 2 6. So I have minus 3x minus 6x. Bring it here. So this one will become 2y plus 3x minus 10 plus 6 equals 0. So I have 2y plus 3x minus 4 is equal to 0. So that is the answer. Once you write all this like this, you will get your full marks, you will get your full points. So please take note of that. If you don't know it before, if you don't know how to solve this question before, I advise you to replay it again, like check it again, you will understand. I'm saying this, if this type of question come out again, you should not miss it. You should get it, you should not miss it if this type of question comes out again. Do you understand my point? So now let's continue. The second one, II. The second one, II, find the angle joining the equation this and this. Now, what is the formula for that angle? See, they gave me 2 lines or 2 equations of a line, of a straight line. So they asked me to find the angle joining them. The angle joining them is, whenever you have something like this, what you need in this thing is the gradient, tan theta. Tan theta is equal to m2 minus m1 over 1 plus m1 m2. This is what you need to use. So, and this is how you are going to get the gradient. So the gradient, this is how you are going to get the angle. The gradient, m1 is the gradient of the first line, m2 is the gradient of the second line. So this is the first line. Make y the subject of formula straight. Y will be equal to minus 3x plus 4. That is what you are going to have. Y equal minus 3x plus 4. So that means m1 is equal to minus 3. Now the second one, y equal, that one has already, we've already made x or y the subject of formula in that one. So m2 is negative 2 for that second one as well. So now this is what will happen. Tan theta is equal to m2, that is minus 2 minus m1, that is minus 3, all over 1 plus m1. m1 is minus 3. m2, that's minus 2. So this is minus 2 plus 3. Minus 2 plus 3 will give me 1. 1 over 1 plus 6. Minus times minus will give me plus 3 times 2, 6. 1 plus 6 will give me 7. So that is 1 over 7. So theta will now be, you just press tan inverse. Tan inverse of 1 over 7. Arctan of 1 over 7. Arctan of 1 over 7 will be, I need to check the answer. Arctan of 1 over 7 will be 8.13 degrees. So you can also confirm with your calculator, you will get this. So that is the answer to this second question, and it is 4 marks. The first one I did here is 3 marks. The second one is 4 marks. Now 2b. I hope you are getting it. So 2b. So you actually need to know how to solve this 2ai and 2. There's no way you can use calculator to solve it. You need to know it actually. You need to know it. So please take note of what we have written down. Now 2b, if alpha and beta are the root of this quadratic equation, and what is the quadratic equation? That is 2x squared minus 5x plus 3 equals 0. Now, if alpha and beta are the root of this quadratic equation, find alpha squared plus beta squared, 1 over alpha plus 1 over beta, all this, you can see what the roots there, right? Now, I'm going to show you how you can actually solve, this quadratic equation using calculator. That's number 1. And I'm also going to show you how you will know whether you are correct or wrong in the examination or when you are solving this. Especially, it does not work for all questions like this, but I'll tell you when it will not work and when it will work. Do you understand? But pay attention first. Now, we know, of course, here a is 2, coefficient of x squared, b is minus 5, and c is 3. Right? Now, Of course, this is what you will be playing with alpha plus beta. You must see, this is very important for you to know. Alpha plus beta is minus b over a, and alpha beta is c over a. So this is minus, b is what? Minus 5 over a is 2. So this is 5 over 2. And c over a is 3 over 2. You need to first know this one. Now, let me tell you something here. I'll be showing you backdoor in the exam, like the backdoor you can be using to cross-check. And a. Now let's solve. Look at the first one. Let's say alpha square plus beta square. You should find alpha square plus beta square. Of course, if you know this very well, I know you will know the formula to use. But if you have not seen it before, I'm going to give you the formula to use now, which you are going to use. When you use it, if you don't know it before, please take note of it. Note it down. You need to note it down and know it, so that if this question comes in the exam, it normally comes in objective question as well, you will be able to answer it. This is alpha plus beta all square minus 2 alpha beta. Don't forget, we are doing theory. You need to show your workings. So you have to be able to write alpha square plus beta square in terms of alpha plus beta and alpha beta. So this is alpha plus beta all square minus 2 alpha beta. Alpha plus beta is 5 over 2. I've solved that already. That's 5 over 2 all square minus 2. Alpha beta is 3 over 2. So this is 25 over 4 minus 3. This is 25 over 4 minus 3. If you find the LCM is 4, or you can just press your calculator so that you don't waste time. 25 over 4 minus 3. This one will give you 25 minus 12 actually, so this is 13 over 4. So the answer to the first question is 13 over 4. How will you know whether you are correct that I was talking about? Let me show you. Or maybe you can't even remember this formula at all. You can't record this formula. Instead of you to leave this question blank and get 0, look at what you should do. Solve this quadratic equation like this is like, no, let me call it backdoor. Backdoor. So backdoor. So now look at what will happen. Solve this quadratic equation 2x squared minus 5x plus 3. You can use calculator to solve it. I'll still show you in the video I'm talking about. I'll show you how to solve using calculator. You'll get 2 answers. Let me solve it. I think I solved it here. The answer is 3 over 2 and 1. So the answer to this quadratic equation is 3 over 2 and 1. Call this first one alpha. Let alpha be 3 over 2 and let beta be 1. They say if alpha and beta are the root of the equation, root of the equation means the solution of this equation. So alpha is 3 over 2, beta is 1. Call it like that. So you will now do alpha square plus beta square. So alpha square plus beta square will now be, what is alpha? 3 over 2 square plus 1. This is 9 over 4 plus 1. If you do 9 over 4 plus 1, you will get 13 over 4. So, which is the answer here. So that shows that you are correct. Do you understand? This is backdoor approach. Do you understand? But in reality, this is what they want you to use. But in case you don't know this one, maybe you are clueless, maybe you just forget, you don't know. Don't leave your answer script blank. Use this method. At least you will get something, because you will get the final answer. If the lecturer is generous enough, you will get your full answer, because what they ask you to find, you got it. Do you understand? But if it's not generous, you will get something because you actually got the final answer. Do you understand my point? So please take note of that. Now the next one. So the next one, B. B is 1 over alpha plus 1 over beta. LCM, you do LCM. LCM is alpha, beta. Alpha, at the end of the day, you have beta plus alpha, or alpha plus beta. It's still the same thing. Beta plus alpha and alpha plus beta are the same. So what is alpha plus beta? 5 over 2. That means 5 over 2 divided by alpha beta, 3 over 2. So you can do it 5 over 2 times 2 over 3. You first write 5 over 2 divided by 3 over 2. 5 over 2 times 2 over 3. 2 will cancel 2, you will be left with 5 over 3. Or calculator can easily do this for you. At the same time too, you can still use your backdoor, that backdoor approach I told you about. you will just continue. Alpha is 3 over 2, so you will now do 1 over alpha plus 1 over beta. 1 over alpha, 1 over 3 over 2 will give me 2 over 3 actually. 1 over 1 is still 1. If you take the LCM, you will see that you get 5 over 3 as the answer. So you can continue to solve it this way. I'll stop now, but let me just focus on this. Now, C is alpha over beta plus beta over alpha. So LCM is alpha beta. Alpha beta divided by beta is alpha. Alpha times alpha, alpha square. You have alpha square plus this one, you have beta square. You've done alpha square plus beta square before. Alpha square plus beta square is 13 over 4. So you have 13 over 4 divided by alpha beta. Alpha beta is 3 over 2. So this is 13 over 4 divided by 3 over 2, right? Divide it into times or use calculator. Times 2 over 3. This one will give you 13 over 6. Don't forget, you can still use backdoor for this one as well. This one will just be 3 over 2. Everything divided by 1 is 3 over 2 plus 1 divided by 3 over 2, and that will give me 2 over 3. If you find the LCM here 6, you see that you get 9 plus 4, which is 13 over 6. You see that you are getting the answer as well. Now, this is backdoor or how to confirm whether you are doing the right thing or you are doing rubbish with confidence. Do you understand? Now, D. For D, what's the last question here? Don't go and see, it's 8 marks. Very big. 2, 2, 2, 2 each. 8 marks. The last one, alpha cube plus beta cube. For alpha cube plus beta cube, this one will be alpha plus beta. Then you have alpha square plus beta square minus alpha beta. Please take note of this. This is how you need to be recalling them in the examination hall. You need to be able to recall them very fast because time is not on your side. You need speed and accuracy. So this is what you have. Please take note of it. Check it well. Make sure you remember. Make sure you remember. Remember it. Now, alpha plus beta is 5 over 2. We've done that. Alpha square plus beta square, we've done that. 13 over 4. 13 over 4 minus alpha beta. Alpha beta is 3 over 2. Right? So this is 5 over 2. LCM is 4. 4 divided by 4, 1. 1 times 13. 13 minus 4 divided by 2, 2. 2 times 3, 6. Don't forget, I will always remind you, calculator can do this very fast. 13 minus 6 will give me 7, right? 13 minus 6 will give me 7. 5 times 7, 35. 35 all over 8. So the answer to that question is 35 all over 8. And I'm done with that. With all these questions I've written in this first place. In that same 2020, question number 4, that's your first semester exam, question number 4B also came out. Like, it's also similar to this. So look at the question now and see the way I'm going to solve it. We are going to be solving it. You can also confirm using backdoor. You will get 35 over 8 as well. Now, for this question number 4, 2020 BI, 4BI, you see that, look at this question. Given that alpha and beta are the root of the equation this, right? Form an equation. You must not get one answer. What I mean, your answer cannot be 2, cannot be 4. Your answer must be an equation. That's what you must do. They say form an equation. Form it, like form an equation. Form an equation whose roots are this and this. Do you get that? Your answer must be an equation, not a value. Do you get that? So, and this is 3 marks anyways. So, but then, whenever you want to form a quadratic equation, this is the general form. Take note of this. X squared minus sum of roots S plus product of roots is equal to 0. So probably let me tell you what these 3 marks is. these 3 marks you are seeing here, they will check. I know that 1 mark will go for the sum of roots, 2nd mark will go for the product, and the 3rd one will go for your final answer. And who knows whether the marks might be more than 3 if such question comes again in your final exam. Do you understand? But then, what is sum of root? Before, you need to find sum of root and product of root. Now, you are given a quadratic equation 3x squared minus x minus 5 equals 0. Alpha plus beta. Alpha plus beta is minus b over a. A is 3, b is minus 1, c is minus 5. Minus b over a. So this is minus 1 over 3. And that will give me 1 over 3. Alpha beta, which is c over a. C is minus 5 over a over 3. So that is minus 5 over 3. Right? You've gotten that. Now, you may want to use backdoor here, but backdoor may not work here. Why? Because if you solve this one, you will be getting an irrational number. I think the answer is 1 plus root 61 over 6, 1 minus root 61 over 6. This one will not help you here. See, basically what they want you to do here is you just need to apply this and this, that's all. But look at what I'm going to do now. So I've gotten this now. Sum of roots. What is the sum of roots? The root is, the first root is 2 alpha minus 1 over beta, right? Plus, this is the first root. And the second root, 2 beta minus 1 over alpha. 2 beta minus 1 over alpha. So this is what we have, sum of roots. That's the sum of roots, means add the roots together. This is the first root, this is the second root. Add it together. So open the bracket. 2 alpha plus 2 beta, write it together. 2 alpha plus 2 beta. Then you are left with minus 1 over beta, minus 1 over alpha. So look at this one. 2 is common here. You have alpha plus beta. Now, LCM is alpha beta. Alpha beta times beta, you have alpha, times minus 1, minus alpha, minus beta. That's what you are going to have, right? Now, then this one will become, this is still 2 alpha plus beta. Minus is common at the numerator. You can bring out the minus so that you'll be left with alpha plus beta over alpha beta. As you can see in what I have written down. In what I have written down now. So, sum of roots is 2. What is alpha plus beta? Minus b over a. We've done that already, 1 over 3. Minus, that's 1 over 3 again, all over alpha beta. Alpha beta is minus 5 over 3. This is 2 over 3. Minus times minus will give me plus. 1 over 3 divided by 5 over 3, the answer will actually be 1 over 5. If you use calculator, you will get it. If you simplify with your hand, you will get this. LCM is 15. 15 divided by 3, 5. 5 times 2, 10, plus 3. So the answer is 13 over 15. That's what I have as the answer. Now, that is for the sum of roots. Now remain product. Product. Product of root means multiply the roots together. That is 2 alpha minus 1 over beta multiplied by 2 beta minus 1 over alpha. So multiply and open the bracket. This times this, you have 4 alpha beta minus 2, because that will be minus 2 alpha times 1 over alpha. Alpha will cancel alpha, you'll be left with 2. This one times this, we also have minus 2 again. Minus times minus plus 1 over beta times this alpha beta. That is what we are going to have. So I have 4 alpha beta minus 4 plus 1 over alpha beta. So what is 4? Alpha beta is what? Minus 5 over 3. Write it. Minus 5 over 3 minus 4 plus 1 over minus 5 over 3. That's what you have. Open this bracket, you have minus 20 over 3. That's what you will have. Minus 4. Plus times minus will give me minus, then swap. This one will be 3 over 5. If you press calculator, you will get 3 over 5. So LCM is, this is over 1. LCM is 15. 15 divided by 3, 5. 5 times 20, 100. 15 divided by 1, 15 times 4. 15 times 4, 60. Minus 15 divided by 5, 3 times 3, 9. So the answer will be minus 169 over 15. So the answer is minus 169 over 15. So that is a product of roots. So the final answer will now be s squared minus sum of roots. Sum of roots is minus 13 over 15 s plus product of roots, that's minus 169 over 15 is equal to 0. So you can multiply through by 15, clearing fraction. Multiply through by 15, you have 15s squared minus 13x minus 169 equals 0. This is the equation. This is an answer. I can say my answer is an equation. You must get an equation. Now, this 4BII. 4BI, okay, I did not put the marks for 4BII, but don't worry. 4BII, if one of the root of the equation, this is 4 times the other, so that 4b squared minus 25ac equals 0. Now, in order not to drop points in this question, this is what will happen. Look at the first thing you are going to write. Let alpha and beta be the root of the equation. That is the first thing, right? So if one of the root of the equation, this is 4 times the other, so that means that if alpha is one of the roots, then beta is equal to 4 times alpha. Do you understand? Beta is equal to 4 times alpha. Take note of that one first. Now, what will happen? They ask me to show this. Now, what is alpha? What is alpha plus beta? Alpha plus beta is minus b over a. You need to know this, of course. You know that before. This is C. Whenever you see this type of question, show that 4b squared equal to ab, or whenever you see this type of question, this is what they want you to play with. Play with alpha plus beta minus b over a and alpha beta c over a. You will get the answer. What you just need to do is you need to make use of these two things. You will get the answer. Now, what is alpha? This one will become alpha plus beta. Beta is 4 alpha. 4 alpha equal minus b over a. Alpha plus 4 alpha will give me 5 alpha. 5 alpha equal minus b over a. Divide both sides by 5 so that alpha will be equal to minus b over 5a. That is the first thing you are going to obtain. Now, you will now come to this second one, alpha beta now. Then alpha beta. Come to this second one, alpha beta. But beta is 4 alpha, don't forget. 4 alpha is equal to c over a, right? This is 4 alpha squared equals c over a. 4. What is alpha? Alpha is minus b over 5a. Put it, minus b over 5a all squared equals c over a. So this is 4b squared, because minus b all squared is b squared, over 5 squared 25a squared equals c over a. Cross multiply. 4b squared times a, 4ab squared is equal to 25ac, a squared times c, 25a squared c. Divide both sides by a. Divide both sides by a cancel a, you will be left with 4b squared is equal to a cancel a, you are left with 25ac. Do you get that? Then bring the 25ac to the other side, you have 4b squared minus 25ac equal to 0. Remember to subscribe to this YouTube channel, please. Thank you very much. Stay tuned as we go to the next round. We go for a commercial break now. Welcome back. So now in this section, now we want to talk about mathematical induction. In 2020, in your first exam, it came out. In 2019, last year, it came out. In 2018, it came out. Proved by mathematical induction, and it's a proof you need to write down. So there's something I'm going to show you how you are going to go about mathematical induction proof. It's just 3 steps. The first steps, let me give you the first step. Number 1, prove it is true for n equal 1. All these things I'm writing, you are still going to get it, like you will get what I'm saying eventually. Prove it is true for n equal 1. That is number 1. Number 2, assume it is true for n equal k. Assume it is true for n equal k. Then third, prove it is true for n equal k plus 1. These are the 3 things you need to put in place before you can solve a mathematical induction problem. But so that you can understand, I will prove that it is true for n equal 1 and 2. But in standard way, you just need to prove for it is true for n equal 1. Once you do that, assume, then these are the 3 steps you need to go through before you successfully prove a mathematical induction problem. This is 3 marks. And this would be 4 marks. This one is how many marks? Do I write it? 5 marks. Now, we want to prove all these things by induction. Now, I want to show you something. There is something you need to know. Summation of r equal 1 to n of r squared. What does this mean? It means r start from 1 to n. Start from 1, 2, 3, 4, 5 till you get to n of what is here. Summation means the adding it. So when r is 1, you are starting from 1. What is in front here? R squared. So this thing means that r is 1, and put 1 here. 1 squared. Summation means plus, add it. After 1, the next number is what? 2. Put 2. On this thing, 2 squared. Plus the next number, 3 squared, 4 squared. It will go on like that till you get to what is up here. What is up here is n. Till you get to n squared. Right? Now, what do they mean that? So we want to prove by induction. So we want to prove that this one, all these things here is equal to this. That is, in other words, we want to prove that 1 squared plus 2 squared plus 3 squared, and it goes on like that till n squared is equal to this one. Is equal to n plus 1, 2n plus 1 over 6. Right? That is what we want to prove. That is what we have. So now, look at it. The first inductive step. Prove it is true for n equal 1. When n is 1. What happened? When n is 1, what happened to the left hand side? This is when n is 1 on the left hand side. This is when n is 1. Left hand side is 1 squared. That is 1. Right hand side is what? n plus 1, 2n plus 1 over 6. Put n to be 1. This is 1, open bracket. 1 plus 1 is 2. 2 times 1, 2 plus 1, 3. 1 times 2, 2 times 3, 6. 6 divided by 6, 1. You can see left hand side is equal to right hand side. Right? You can now see thus it is true for n equal 1. That is that I've just finished this number one. Prove it is true for n equal 1. I've just finished proving it here. Do you get that? Let me, so that you will understand it too. Assuming I'm in the examination hall, I will go to number 2 straight. Assume it is true for n equal k. But let me show that it is true for n equal 2 so that you have a ground understanding of what we are talking about now. When n equal 2, what will happen to the left hand side so that you will see what I'm saying. Don't go and pick to only 2 square. When n equal 2, it means that you will do 1 square plus 2 square. That is what I want to show you. When n is 3, you will do 1 square plus 2 square plus 3 square. When n is 4, 1 square plus 2 square plus 3 square plus 4 square. Do you understand? So left hand side will be 1 square plus 2 square. That is 1 plus 4, 5. That is the left hand side. Right hand side will be what? Don't forget, this is the formula for the right hand side. n plus 1, 2n plus 1 over 6. So n is what? 2. This time around n is 2. 2 plus 1 is 3. 2 times 2, 4, plus 1, 5 over 6. 2 times 3, 6. 6 plus 6 times 5, 30. 30 divided by 6 will give me 5. You can see again, left hand side is equal to the right hand side. See, thus it is true for n equal 2. So in reality, I prove for n equal 1, I prove for n equal 2. But in the examination, in order not to waste time, just prove for n equal 1. Then go to the next one. Assume it is true for n equal k. So now, so that is the first step. So you now say assume. That's the second thing. What I wrote down before I drop it off. It is true for n is equal to k. Assume it is true for n equal k. And what will that be? It means that anywhere you see n here, replace it with k. N equal k. Replace anywhere you see n with k. This one will become 1 square plus 2 square plus 3 square plus you get to, instead of writing n square, write k square is equal to k plus 1, 2k plus 1 over 6. That is what you assume. So you've written that. The last thing to do, we now prove for n equal k plus 1. That is, we now prove that it is true for n equal k plus 1. Look at what will happen here. Let me show you something. Right? Let me write all these things. You see, you will start from what you assume. That is where you will start from. Look at what I'm trying to say. Look at this place. Look at what, this is what I assume. Assume it is true for n equal k. This is what I've written. I have 1 square plus 2 square plus dot 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 till I get to k square is equal to k plus 1, 2k plus 1 over 6. Right? Now, see what will happen. I will add, it is true for n equal k plus 1. I will add k plus 1 to both sides. Don't forget, this is the form n square. Add k plus 1. Assuming it's n cubed, I say I will add k plus 1 cube. So I will add k plus 1 all square. For us to prove it, k plus 1 all square, you can say I've added it. That's what I wrote in blue. Plus, what to do to the left hand side, you do to the right hand side. Add k plus 1 to both sides. Do you understand? So that is what you want to do. Now look at how will you know you are correct. See, when you now solve, you simplify this right hand side. How will you know you are correct? Come to back door. Let me show you back door. Sharp. Look at this thing. n plus 1, 2n plus 1 over 6. Replace everything with k plus 1. Replace n to be k plus 1 here. Replace anywhere you see n, 2k plus 1. You know, this n will become k plus 1. This one will become k plus 1 plus 1. Don't forget, anywhere I see n, I'm putting k plus 1. This is k plus 1. This is k plus 1. You know, there's 1 plus 1 before. Plus 1. This one will become 2 open bracket k plus 1 plus 1 all over 6. So this one will eventually become k plus 1. 1 plus 1 will give me 2. So this one will be k plus 2. So an error occurred actually, but let's continue with the proof now. So I'm here. I said that we want to prove for n equal k plus 1. So I told you that you add k plus 1 to both sides of the equation. Then I wanted to show you how you are going to get, like how will you know you are correct. So you are going to simplify this right hand side and you must get an answer. The answer you get will determine whether you are correct or wrong. But let me show you what you are going to get or what you must get so that you will know that you are correct. So this is, I said that this is n plus 1. Replace all the n's with k plus 1. You know, when n equal k plus 1, replace all of them with k plus 1 so that we have, this one will become k plus 1. This one will become k plus 1 plus 1. Then this one will become 2n, 2k plus 1 plus 1 all over 6. So at the end of the day, this one will be k plus 1. K plus 1 plus 1 is 2. So that is k plus 2. Then I have 2k times 1, 2k plus 2. 2 plus 1 is 3. So I have 2k plus 3. 2k plus 3 all over 6. So that's what I'm supposed, that's what I will get. Once I get this, then that means I'm correct. But if I don't get this, then there's an error somewhere. So to prove for n equal k plus 1, so I start from here. Look at what is common here. Factorize. K plus 1 is common. Factorize it. So I have k plus 1. What are you left with? You will be left with k. 2k plus 1 over 6 plus, you know, this is square. You have factorized 1, it will remain 1 of it. So you plus k plus 1. That's what you are going to have. So this is k plus 1. LCM is 6. 6 divided by 6 is 1. 1 times all this one is still the same thing as that thing. But let me open the bracket at once. K times 2k, that is 2k squared plus k times 1k plus 6 divided by 1 is 6 times all this. So 6 will multiply all this. So 6 multiplied by k plus 1. That's what you are going to have. So this is k plus 1, 2k squared plus k plus 6k will give me 7k. 7k plus 1. 2k squared plus k plus 6k plus 6. 6 times 1 will give me 6. All over 6. That is what I'm going to have. So I will factorize what is at the numerator. You have to know how to factorize this. Factorize what is at the numerator. You will see that this one will actually give me k plus 2, 2k plus 3. So if you factorize what is at the numerator here, or just expand this. Now let me give you one hint. If you don't know how to factorize this thing, just check your final answer here. You know, you have k plus 1 here, right? This is k plus 1. That means this thing must factorize, must factor to these remaining two things. K plus 2, 2k plus 3. Just write it there. Don't show it. In fact, even if you see that you make mistake somewhere and you can't find your mistake, instead of missing the question totally, just write. Since you know where you are going to, just write. Don't show full workings. Just write the answer. All over 6. So the lecturer will know that you know what you are doing, like this person knows what he's doing. It means that they don't understand what he has written down. Do you understand? Instead of getting 0, you will have some point, even if you don't have all the whole point. Do you understand? So you stop here and to just confirm you are correct, you can just expand this, you get this. Do you understand? So then you now say thus. It is true for n equal k plus 1. And you are done with induction. You have shown the 3 steps. You know, I told you it is 3. Number 1 is prove it is true for n equal 1. Second one is that you prove that, assume it is true for some n equal k, then you prove for n equal k plus 1, and you have done that. So therefore, you just round up, write the question again for them, and that's all. Summation of r starting from 1 to n of r squared is equal to n plus 1 2n plus 1 over 6, and that's all. You are done. You are done proving with induction. And if you have written all those things I have done, you will have your full marks. You won't lose any point at all. That's induction. You understand? Look at it. This is your first semester exam 2020. This question came out. The same question came out in 2019. It is also proved by induction. You can see that it also came out in 2019 question 2a. That I should prove this by induction. But remember, this one and this one are the same. You just change R to K. That's all. So the same way you have proof for all these ones, that's how you are going to prove this. See? So I don't need to prove 2019 again, but let's do BI, 3BI. Let's do question 3BI. Summation R starting from 1 to 4 and 3 open brackets minus 2 over 5 raised to the power of n minus 1. So look at this one. Actually, you can use calculator to solve this directly. I will still show you how you can type this. But if you look at your calculator very well, you can just input all these values there. I will still show you in another video how to use calculator to solve this. But don't forget, this is a theory question. This is a theory question, so you need to show workings. And what does this mean? You see, R start from 1, stop at 4. That's the meaning of this. And the summation. Summation means addition. Addition of what is in front here. So this is equal to, this is 3. Now look at what I'm going to write. 3, pay attention, minus 2 over 5. R start from what? Oh, so this is supposed to be n. So this is supposed to be n. I know it's a mistake here. So n starts from 1 and stop at 4. So n is 1. So that means you do when n is 1, when n is 2, when n is 3, and when n is 4. You start from 1 and end at 4. So this is when n is 1, put 1 there. 1 minus 1, 0. So this is 0. Don't forget it's summation. Summation means add plus the next number. You will be adding what is in front here. That's what you are going to be adding. No, what is in front here. That's what you will be adding. You have 3 minus 2 over 5 raised to power. Now you know I've done for n equal 1. Do 2. 2 minus 1 is 1. So that's for n equal to the next one 3. This is plus 3. You can see it is what is in front and right now. I'm just changing n, and I started from 1 and I will stop at 4. So I've done for 1, 2. This the next one is still now minus 2 over 5 raised to power 2, because 3 minus 1 is 2. Then lastly plus 3 minus 2 over 5 raised to power 4 minus 1, 3. So the answer to this one, anything raised to power of 0 will give me 1. So this one will just be 3 plus, now anything raised to power 1 is still the same thing as that one. So this is minus 6 over 5. 2 over 5 whole square will give me 4 over 25. 4 times 3 is 12. So that is plus 12 over 25. Minus, because you know, square minus 2 times minus will give me plus. But this is cube now. Minus 2 times minus, you can just use calculator to just use calculator, press the value. It will give you the answer. Minus 2 over 5 raised to power 3 will give me minus 8 times 3. That is minus 24 all over 125. That is what you are going to have. Then you add all these things together. When you add all these things together, what you have, you use calculator to calculate all these values, so that you know the LCM is 125. 125 divided by 1, 125. 125 times 3, that is 125 times 2 is 250. 250 plus 125, that is 375. So this is 375 minus 125 times 125 divided by 5, that is 25. 25 times 6 is 25 times 4 is 100. So 25 times this is 150 plus 125 divided by 25 will give me 5. 5 times 12 60. 60 minus 24. So that's what I have at the end of the day. So 375 minus 150, that will give me 225. 225 minus 24, or 225 plus 60, 225 plus 60 will give me 285. 285. 285. 285 minus 24. 285 minus 24 will give me 261. So the answer is 261 over 125. So it's a matter of computation. So you can just you don't need to stress yourself finding LCM. Just type all this on your calculator. You will get the answer. It's as simple as that. You will just get the answer straight. So you don't need that. So, and even to solve this whole question at once, I can give you a way of I'll still show you how to solve this using calculator or to confirm your answer in the examination hall. So now the next one, I want to prove 2018. Now you can see another question on math induction came out in 2018. It came out in your first semester exam 2020. It came out in 2019. It came out in 2018. So let's see how you will do it. So the same principle still applies that the same principle I told you about. So we are still using the same principle of math induction here. And what am I using now? So 2018 question 1b. Now they say prove by mathematical induction that this is an integer multiple of 3. That is, we want to prove that 5 raised to power 2n plus 3n minus 1 is divisible by 3. That is a multiple of 3. That is, 3 can divide it. That's what we want to prove. And we want to prove it by induction. You need to understand the question first. So this one is divisible by 3. And don't forget the 3 steps. You know, I've given you the 3 steps before. That number 1 is prove that it's true for n equal 1. Number 2, assume what? Assume it is true for n equal k. Then lastly, prove for n equal k plus 1. So now when n is 1, so you just start. They are told you to prove by induction. So start by when n is 1. When n is equal to 1. So put this one here. You will prove that 3 can divide the answer you get from this thing. So you will have 5 raised to power 2 times 1 will give me 2 plus 3 times 1 is 3 minus 1. 5 raised to power 2 is 25. 25 plus 3 minus 1. 25 plus 3 is 28. 28 minus 1 is 27. In fact, you can see 3 can divide 27. So this is the same thing as 3 multiplied by 9. 3 multiplied by 9 is 27. So you can see, I can now say thus, because obviously, once I factorize 3 out of a number, you can see that 3 can obviously divide it. So thus, it is true for n equal 1. That is, 3 can divide it. That's the first thing. Now, assume it is true for some n equal k. Now, for this type of equation, now we say assume it is true for some n equal k. So what does that mean? What does that mean? If it is true for some n equal k, that means you will replace n with k here, and it must be an integer, and it must be a multiple of 3. That is, 3 can divide it. So that means that, look at what I'm going to write. It means that 5 raised to power 2k plus 3k minus 1 must be a multiple of 3. Must be equal to 3 something like that. When n is 1, the p here is 9, because 3 times 9 will give me 27. So I will write equal to 3p. So I will now say where p is an integer. Where p is an integer, or I just write it this way, where p belongs to the set of integers. So now I want to prove for n equal k plus 1, but there is something you need here. You will need this assumption. Don't forget, when I prove the first one, I use that assumption. That was what I used to prove n equal k plus 1. That's what you also need here too. But look at what I'll do. I'll make 5 raised to power 2k the subject of formula first. If I make 5 raised to power 2k, it still means that 5 raised to power 2k is equal to 3p. Bring this one here, it become minus 3k. Bring this one here, it become plus 1. Let me call it 1. Now, we now prove for n equal k plus 1. We now prove for n equal k plus 1. That is, when n is k plus 1, it will still be divisible by 3. And how will you know it is divisible by 3? That means if you are able to factorize 3 out of it, then it is divisible by 3. So now put k plus 1 here. Anywhere you see here, put k plus 1. So this one will become 5 raised to power 2 k plus 1 plus 3 k plus 1 minus 1. What will this one be? If you open the bracket here, this one will become 5 raised to power 2k plus 2 plus, open the bracket here, 3k plus 3 minus 1. So look at what will happen here. No, don't forget from the law of indices. Don't forget from the law of indices. When you have a raised to power m plus n, what does that mean? It means a raised to power m times a raised to power n. Or you know it this way, a raised to power m times a raised to power n equal a raised to power m plus n. The same thing happened here. 5 raised to power 2k multiplied by 5 plus 2. This one will become 5 raised to power 2k multiplied by 5 raised to power 2, and 5 raised to power 2 is 25 from the law of indices. This bracket means multiplication. So plus, then I have plus 3k. 3 minus 1 is 2, that is plus 2. So now what will happen? I have made, so this is 25. 5 raised to power 2k. 5 raised to power 2k. What is 5 raised to power 2k? This is it. 5 raised to power 2k is equal to 3p minus 3k plus 1 plus 3k plus 2. That is what I'm going to have. So open the bracket. This is 25 times 3 is 75. 75p minus, right, minus 75k plus 25 plus 3k plus 2. So I have 75p minus 75 plus 3. That is minus 72 minus 72k. 25 plus 2 is what? 27. You know, this is, what am I evaluating? I'm evaluating 5 raised to power 2k plus 1. I'm doing for n equal k plus 1. Is it not obvious now? Look at it. I factorize 3 out. This one will become 25p minus this one will become 24k plus 9. What does that mean? I factorize 3 out. That means it's a multiple of 3 because I can factorize 3 out of it. So thus, or I'm just write, which is a multiple of 3, right? Therefore, thus it is true for n equal k plus 1. That is how to prove math induction. So therefore, at the end of the day, what do we have? At the end of the day, we are done with the proof. So we just write conclusion. Therefore, 5 raised to power 2n plus 3n minus 1 is a multiple of 3. So if this question comes out in your exam, you must get it. Let's wait for the next question. Let me write out the next question.